So with this question, we've got a little bit of information here. First of all, Stefan has been surveyed by a different group of randomly chosen students, and we find about different types of television programs. And we find here that the probability, we found that 2/3 watch sport and 4/9 watched a movie. So the probability of watching sport is equal to 2/3, and the probability of watching a movie is equal to 4/9. And we can also see there that if 4/5 of them had watched at least one of sport or movies, okay, and or is the key word there. Or means union, at least one of sport or movies. That's a typical phrase for something that means the union. So therefore we can say the probability of sport and movies is equal to 4/5. Now, the next thing it's being asked in the question there is, what is the probability that a randomly chosen student watched both sport and movies? So when it says both and movies, that means you're looking at the intersection. Okay, so we're looking for the probability of S intersection with M. So we know that there's a formula for the union that goes something like this. The probability of S union M is equal to the probability of S, which is sport, plus the probability of watching a movie minus the probability of the intersection of both sport and movies. Now, we know that we've got all the information here apart from what we're actually looking for, which is the intersection between the two. So let's substitute some values in. So the probability of the union of sport and movies, we've been told, is 4/5. So we say 4/5 equals. The probability of sport is 2/3. Okay, so there's the plus probability of S, plus the probability of movies is 4/9. And then we go minus the intersection of sport and movies, which we don't know, we're actually trying to find out. So now what we do is we have to move these fractions over to the other side of the equation so we can kind of isolate what the intersection is. So we end up with 4/5 minus 2/3 minus 4/9 is equal to negative the probability of the intersection which we're looking for. And if we work out 4/5 minus 2/3 minus 4/9, we end up with minus 4/15 is equal to negative the probability of S intersection M. Now we know that because we've got a negative on both sides, we can cancel them out. So therefore our answer, the probability of S, or the intersection between S and M, is equal to 4/15, or if you're wanting to put it into a decimal, 0.311. That's how you work at that question.